Hello, my name's Andy Beaton. I've been doing this a few times. I expect a few of you will recognize the routine I'm going to go through, but I'm going to talk about what's up in the sky this month. And I'd like to thank everybody who has taken time out from watching hockey to join us tonight. I have my usual list of things I like to go through, the big picture, key dates, the sun, meteors, the aurora, the moon, planets, asteroids, and comets. Always a double star, absolutely always a variable star, something in the deep sky, whatever's coming up in the world of spaceflight, and some backup plans just in case it's cloudy. So the big picture, if we head out there tonight at 10 o'clock, look west, this is what we're going to see. Our favorite winter constellations are finally disappearing. Orion's just sticking his nose up above the horizon. Your spring constellations, Cancer and Leo, are following. Pretty good night for the moon if you like that kind of thing. The Terminator's halfway through, so you can see some good shadows on the craters and mountains. But not much in the way of planets. Jupiter's kind of disappearing there. Mars is still good, but other than that, not much. This is the kind of month I hate, where there's nothing really spectacular happening in the sky I can talk about. But by the next meeting, things are going to start happening again, especially in the morning sky. Get up at 4 o'clock before we have any sunlight showing up. We'll start to see all our favorite planets showing up just over the horizon. We have our summer constellations. We've got the summer Milky Way. And we're ready for all our favorite summer viewing. So important dates coming up. The first one is a date that's actually passed. The Eta Aquariid meteor shower peaked last night, but it's a 5-day long shower, so we should be able to see some as long as we're under reasonably dark skies. Another one that's passed, Saturn's ring plane passed the sun, so the other side of Saturn's rings will be illuminated for a good long time. May 27th is going to be the new moon. That's when all our photographers are going to be out taking advantage of the darkest sky we're going to get this month. And we have our last double moon shadow on Jupiter. If we're ever observing Jupiter through a telescope, every now and then one of Jupiter's moons will cast a shadow on the surface. When things are properly lined up, like they will be this month, you can get 2 shadows at the same time. So that's something to look forward to. It's interesting more than exciting, but your observer's handbook will have exact time and end dates for your shadows on Jupiter. So the sun, nights are getting longer. Astronomical twilight is ending at 10:15 tonight, starting again at 3:40 in the morning. So we don't have a lot of dark sky to observe in, and it's just going to keep getting worse. By the next meeting, twilight ends at 11:10 and starts again at 2:50 in the morning. And it's going to keep getting worse until as we approach the summer solstice. What the sun is good for right now is activity. There's a massive sunspot group on the surface of the sun right now. I haven't been out to see it with a solar telescope myself, but I've seen it reported online by a number of people. It's a nice big one. The thing I hope is that this kind of solar activity is going to result in a nice bit of aurora for us to look forward to. That's about all I can really hope for from the sun. It's not really looking like there's anything predicted for tonight or the next few nights, but we've got a whole month ahead of us. Meteors, it's not a great meteor time. The best we have is the Eta Aquariids from last night. We'll still have a few more nights of them. We could probably expect 30 to 60 meteors an hour. The moon's pretty bright, so of those 30 to 60, we're not going to see too many. That's the closest thing we have to a major shower over the next month. We've got a minor shower, the Eta Lyrids, on May 10th. and we have a really tiny shower, the daytime Arietids, less than 2 meteors an hour. I wouldn't go outside to search for them, but if you're interested in a science experiment, dig out your old radio, tune it to a distant station, say Montreal or Ottawa or something. You aren't going to pick it up until a meteor passes overhead. When that happens, the ionization in the atmosphere will reflect the radio, and you'll pick up a brief burst of music or news from that distant station. It's the funnest and easiest way to do radio astronomy, and one of the best things you can do during a day, especially if it's cloudy. So we also have the Tau Herculids peaking on June 2nd. That one's a variable meteor shower. And what that means is you're taking your chances. You might get a million, you might get none. I wouldn't plan for anything, but if you're out there and you see meteors, trace them back to the direction they're coming from, see if they're coming from the area of Hercules, and see if you can identify members of this, this variable shower. So the aurora, as I said earlier, nothing too exciting predicted in the near future. I would watch spaceweather.com as my source of information on when meteor or when aurora are expected. The picture on the screen there is one my daughter took at last summer's fantastic aurora display out on the West Coast. I didn't get to see anything like that in Toronto. I got to see little streaks, but it's not very often you see aurora in the city. So I'm hoping we can get a decent display sometime this summer. I think we deserve one. The moon, full moon's on the May 12th, last quarter on May 20th. The new moon, that's the important one, May 27th, and then the first quarter on June 3rd. Apogee is on May 11th, and perigee is on May 26th. I never remember which one's apogee and which one's perigee, so I threw in a note here. Apogee is when it's far, perigee is when it's close. And if you're looking for a fun science experiment with the kids, take a picture of the moon on those two dates with the same equipment and compare the size of the two images. You'll get to see that there's a real measurable difference. Evidence that the moon orbits in an elliptical orbit and not a circular one. Lunar X, it's going to be in the daytime. For those who don't know, there's a few craters on the moon that once a month they get illuminated at a certain angle and it makes an X, the light shining across the two crater rims. Scientifically, it means nothing, but it's neat. It's a cool thing to look at, and it's a fun thing to have a target to go hunting for. Unfortunately, it's at 9:18 in the morning. I haven't tried spotting in the daylight. I think with any reasonable telescope, you probably could, but I haven't done it. If anybody wants to try it and they succeed, please let me know. I'd be very curious. The straight wall, another lunar feature that looks really cool through a telescope. It lasts longer than the Lunar X, but it's a bigger feature. Anytime during the evening of May 7th, it's down towards the south edge of the moon. It appears as a very weird looking straight line that you don't expect to see on the moon with all its circles and bumps. The rocky planets, Mercury is not really well viewed from here in Toronto. I know in the past we have had people in the Southern Hemisphere listening in on this talk, so you guys are going to get a really nice view of Mercury. It will show up in the morning, nice and high for Mercury. For us, it's an unfortunate angle. It ends up quite close to the horizon for us, even at its best. Mercury, or Venus, is also in the morning sky, higher than Mercury and way brighter. You're not going to miss it. It'll be really obvious, but also at a funny angle. Over the next month, it's heading around the sun to the back, which means it's going to be gibbous, it's growing fatter, it's going rounder, but because it's going further away, at the same time, it's going to be getting less bright. The best of the rocky planets is going to be Mars. It's a first magnitude object in the western sky at sunset, nice and high, but yay high, and setting not long after midnight. Currently 6 arc seconds across, which means with any decent telescope, you should be able to see polar caps. A large telescope, you should be able to see some kind of surface features. But you want to get it while it's as high as possible in the sky, because the closer it gets to the horizon, the crappier the viewing is going to be. It'll be traveling from Cancer to Leo as the month progresses. And once again, I'm going to ask people to see if you can see Mars's moons. Another thing that I have never seen, and I'm curious if other people can manage it. It's tricky. You really need to block Mars out of your view and get that very faint moon just on the edge of the eyepiece, because they're very faint compared to Mars. The gas giants. Jupiter is low in the west at sunset, and it's getting worse as the month goes on. I would not even call it an interesting target at this point. You should be able to see it with a telescope and see stripes and moons, but viewing conditions are going to be terrible just because it is so low. Saturn is rising before dawn in Pisces, and it's got the same problem. It should be interesting, but it never really gets very far above the horizon during the dark hours. And over the next month, the position is improving, it's getting higher, but at the same time, the sun is rising earlier. So it's not going to get out of dawn twilight over the next month. The other problem with Saturn is the rings are at a very flat position right now. If it were in a better position, I would say that would be good. It would be a good time to look for interesting weather features, look for the small moons of Saturn that are hard to see under other conditions. But right now, it's just a curiosity seeing flat rings. The ice giants, we can pretty much write off for this month. Uranus is too close to the sun. We're not going to see it at all. Neptune rises in Pisces. It's close to Saturn, but the same problem. It's not going to get out of twilight, and twilight gets worse and worse as we approach the summer solstice. So put those ones on hold until later in the summer. The dwarf planets, it's actually not a bad time to go looking for Pluto. It's in Capricornus. It's just over the border from Sagittarius. It's moving slowly. As it gets further and further away from the Milky Way, it gets further away from the really dense clouds of stars, making it a bit more easy to identify. It'll rise tonight somewhere after 2 o'clock. So by morning twilight, it'll be as high as it gets, and that will improve as the month goes along. 14.5 magnitude, that's tough for visual viewing. There are going to be a lot of faint stars that will make it hard to identify. Best way to go hunting for Pluto is photographically. Take a picture, come back 3 nights later, take another picture, and look for the dot that moved. The other dwarf planet we are able to see is Ceres. It's in Cetus, low in the horizon in the dawn throughout May. 8th magnitude. It's findable. It's not really great because it is going to be pretty low, but you can track its movement. It moves pretty fast, usually about 5 minutes from night to night. And tracking it as it moves would be another interesting science project. Got a few asteroids brighter than 10.5 magnitude. Juno and Vesta are the most spectacular ones. They're going to be not far off visible to the naked eye, probably 7th or 8th magnitude. The others much dimmer, but tracking asteroids is fun. They do move. If you're out from night to night and have the patience to do it, mapping them is interesting. I remember in university actually taking asteroid coordinates and measuring them and trying to calculate the orbit. I had to do it for marks, so it wasn't really a fun project, but it was enjoyable. I'm not going to try and give you coordinates for all these. They're available in the RASC Observer's Handbook or planetarium software, which I expect most people watching this will have on their phones or their computers. When I was complaining earlier about how this is a lousy month for spectacular things to look at, comets was at the top of the list. It is a terrible month for comets. The best we have at this point is F2 Swan, 8.5 magnitude in Taurus. It's close to the sun. You might catch it at sunset, but it's not really it's not going to be a high contrast object. It's marginal at best. The only other one greater than 12th magnitude is A3 Tsushinshan Atlas, just under 12th magnitude in Vulpecula, slowly moving into Cygnus over the next month. 12th magnitude comet is interesting only if you've never seen a comet before and want to say you have. I guess if you're the kind of person who wants to check off every possible thing in the night sky, you can go after it, but it's way, way, way past its peak. So we have to have a double star. This is for my old friend Blake, who got me interested in observing double stars. I'm going to go for a spectacular one this time, Alpha Canum Venaticorum, also known as Cor Caroli, or old-fashioned way, Cor Caroli Regis Martyris. And this is named after King Charles I of England, after he had his head lopped off. Once the monarchy came back to England, they decided that he was a good guy after all, and they honored him by naming this double star after him. So that's where the name comes from, if you're wondering. It's a 2.5 and 5.6 magnitude pair, 19 seconds apart, so any small telescope should be able to split them. They're both bright enough to be seen with the naked eye under a dark sky. Blue and white in color. The bright one is blue, the fainter one is white. I mean, it says green in the Observer's Handbook, but anybody who's ever looked at a star that's supposed to be green knows it looks white. But the bigger telescope you have, the more photons you're going to get, the more obvious the color difference is going to be. And for you younger astronomers, I strongly suggest you take very careful notes of where these two stars are. And every 10 years, come back and take another look and see if you can track it as it orbits the primary. So here we go. There's the finder chart. Up at the top, we have the handle for the Big Dipper. If we consider the handle of the Big Dipper to be the outer edge of the piece of pie, Cor Caroli is right at the center of the pie. It's easy to find. It's nice and bright. So it makes a good party star if you're showing friends and family some cool stuff in the sky. Now, you know you're not going to get away from my talk without a variable star. So here we go. RS Canum Venaticorum, same general area in the sky. It's a close eclipsing binary. We have an F main sequence star and a K, which is a much redder subgiant secondary. And it varies from just under 8th to just over 9th magnitude every 4.8 days. It's your typical eclipsing binary, but it's more complicated than that. The secondary is undergoing rapid spinning. The magnetic field of the primary is messing it up. So it has huge sunspots that change the star's brightness as they rotate around the star. The changes for this are subtle, so you'll want a photometer for this one if you're going to go for the subtle changes caused by the sunspots. But if you're looking for just a regular eclipsing binary, that can be easily done visually. Maps for the variable star can be found at the American Association of Variable Star Observers website. They have charts where they have comparison stars for all the interesting variable stars. You look at this star, you compare it to nearby stars, say, okay, it's brighter than this one, dimmer than that one, it must be 8.5. You can record it, send it in, and join the database of 120 years of variable star data that have been accumulated by amateur astronomers. Professional astronomers, as a rule, don't have time to go looking to measure variable stars over months and years. So that's where we amateurs step up and do our bit for science. And the weirdest of all variable stars, T Corona Borealis. We've been expecting the outburst for over a year now. We don't know why it's not happening. This one is, we had thought, one of the most predictable events in the sky. 1946 for the last outburst. Last year was supposed to be the next outburst, and it hasn't happened. It'll be bright enough to be visible to the naked eye, but we're just not seeing it, and nobody knows why. It's going to be pretty bright. Here we have a map of Corona Borealis with the bright stars and the blaze star down in the corner, so you can have a rough idea where you're going to be looking. If you see it there, get online and report it. This is something that scientists have been eagerly waiting for a long time, and it's going to be people like us who are out there observing every night who are going to tip them off that it's happening. Something in the deep sky, M4, fourth object in the Messier catalog, is a globular cluster in Scorpius. It's easy to find, it's bright, it's a 6 magnitude, and it's right beside the star Antares, so nice and easy to find. Closest globular cluster to Earth, about 100,000 stars. A large number of them are white dwarfs. This is a very, very old cluster. Some of the stars approaching 13 billion years old. That's where the oldest observed star in the Milky Way has been recorded. And with a small telescope, you should be able to resolve a number of the stars. I think globular clusters are the most interesting visual objects because they're the ones that look best to the eyeball. Other things, cameras pick up more light. The longer you observe, the more detail you get. Globular clusters, they tend to burn out in the center and just make a white blob with photography. So I like looking at them just with the naked eye. I think that's the best way to really appreciate them. Now, I know that some of the people sitting in this talk are looking for something more challenging than Messier objects. So for them, I'm going to point out NGC 40, 38, and 39, the antenna galaxies. 10.5 magnitude interacting galaxies in Corvus. And this is them. This is actually from the Hubble telescope, so don't expect to see that. But it is two galaxies crashing into each other and all kinds of interesting effects going on there. An 8-inch telescope will be able to find it. Larger telescopes, especially say something over 16 inches, so you'll start seeing the structure and clearly distinguishing the two galaxies. You should be able to see bright patches. You can see the around the edge there where there's a lot of star forming activity as the two galaxies crash into each other, and a lot of dark material around the center, a lot of dust and gas that's going to be, that predicts future star formation as well. And as you can see, I can't type antenna, so we'll pretend that didn't happen. Coming up in space flight, it's actually an alarming space flight time. Cutbacks in the US government mean a lot of the interesting space programs are in jeopardy. We want to keep an eye on that for the near future. An Eris rocket is being launched from Australia. This is a brand new spaceflight company. May 15th is a scheduled date. As always with test flights, we don't know when it's really going to go, but that's the scheduled time. Cosmos 482, a Soviet Venus lander that failed to get out of Earth orbit, is expected to crash sometime on the night of May 9th or 10th. I don't know where it's going to happen. It could be quite spectacular. The odds of it landing on anybody are pretty low, but keep an eye out for it. The ISS will be passing overhead late night and early morning until May 28th. After that, its orbit is in a position that's means we're not going to see it here in Toronto, but other people at other places around the world should be able to see it. Something else that I have found this month on the Heavens Above website is the Tiangong, the Chinese space station, should be visible early morning until May 28th. And after that, evenings low in the south. I think it gets something up to 30 degrees above the horizon. Heavensabove.com is where to go for more details on when and where it will appear. Space stations are just cool things to see in the sky. I love them. You know, seeing an object, a bright object going overhead and knowing there are astronauts up there is just always fascinating. So if you're in Winnipeg to see the jets and you're too far north and there's no night, Galaxy Zoo has an abundance of citizen science projects, places where people like us can go and contribute ourselves to science. They have dozens of projects. I've picked a few that looked interesting this month. Cosmic collisions, sunspot detectives, looking for sunspots and tracking them. Gamma ray burst chasers. That's for helping track down gamma ray bursts. The professional astronomers will gather a ton of data, and people like you and I will go and dig through it and try and track down what is actually happening. And kilonova seekers, for those of you who really love those giant explosions in space when neutron stars crash into each other. Well, who doesn't? So obviously, once again, if there are any questions, I'm happy to answer them. You can email me at andy.beaton@gmail.com. I'm on Blue Sky or the Toronto Centre Forum. And thanks very much, and clear skies. And are there questions?
Yes, any questions from the audience?
You mentioned the transits of Jupiter. Titan transiting Saturn, I think it's still visible. Did you get a chance to look into that at all?
Saturn is in such a terrible position for observing right now that I did not. It would take a better sky than its position close to the sun right now to be able to see something like that, I think. Now, I could be wrong. If somebody can observe a transit of Saturn or a shadow of Saturn, I'd be fascinated to hear about it. And yep. And let me know in the places I mentioned.
There are some coming up about once every 16 days or so through September. So
okay, well, actually, as we get further into the summer and Saturn gets further away from the sun, that would be an interesting observing project, looking for Titan crossing the face of Saturn or its shadow. So yeah, keep an eye out for that. Is this something, Dennis, is this something that's in the Observer's Handbook? Is this something you're going to have to go dig out your planetarium software for?
I'm just looking at something on cloudy nights, but I think
Okay.
probably in the observer's handbook, but you never know.
Yeah.
And because of the nature of this event, it's only 5 hours. You've got to be on the right side of the Earth to see it. So there may only be 1 or 2 opportunities from North America that'll work out.
Okay, so cloudy nights is the place to look for information about transits of Titan.
Okay. Any other questions in the room? No. Okay. And no questions online. Andy, thank you very much.
Okay,
and
thank
ladies and
you.
gentlemen, we're going to go to fun facts while we get set up for our next speaker.